So what do you get when you plug in negative 1? Y cubed plus negative 1y. And then you plug in 0 for x, and what do you get? Y cubed plus 0 times y. And then you plug in 1 for it, and what do you get? Y cubed plus 1 times y. Can you simplify all three of these? You can. Let's keep talking to myself. It's okay. You can. So you get y cubed, and you get y cubed plus y. So you get three things. Where are those three things? Well, in this space right here, where does x equal 1? X equals 1 right here. Let's call that x equals 1 right there. What is the plane where x equals 1? Remember, what do you do with the lines? They are all, when you draw them, they're all parallel to the x, y, or z axis. So where does x equal 1? X equals 1 right here on this plane. Where does that plane cross? It crosses right there at x equals 1. When x is equal to 1, this is what you have. Y cubed plus y. What does that graph look like? When y is 0, what is it? It's 0, right? It's right here. And then what does it do? It goes up, right? So it kind of goes, that's a bad curve, I'm sorry. What does it look like? It looks like, I think it looks like this, like that. So what is that? Y cubed plus y. Does everybody see that right there? Does that make sense for that color right there? So I'm going to use a different, I'm going to call this one the red one. Where does x equal 0 for this one right here? Where does x equal 0? So this is the green one. Where does x equal 0? This is harder to draw, everybody, because there's going to be multiple ones. Where does x equal 0? Right here. What plane am I going to have to draw there? The what plane? Y, the yz plane. When x is equal to 0, it is the yz plane. I'll use green now. Where's that one going to be? Sorry, I'm going to use dotted lines here to try to draw this a little better. It goes behind like this. And where does that cross? It crosses right here. Well, that's just y cubed, right? So what does that one look like? Very similar, right? There's y cubed. But what about the last one? Where is this one right here? X is equal to what? The purple one is x is equal to what? Negative 1. So that plane is behind. It's back here. That's x equals negative 1. So that plane is behind all of them right here. I'm doing my best here. This is hard to do. Y cubed minus y. What does that look like? It's a similar shape, right? But it goes down a little bit. So what does this one do? It goes down, and then what does it do? It goes back up. This one goes up and then back down. If you were standing right here, everybody, if you were standing right here and you looked this way, what would you see? You would see this plane here. You'd be looking at a wall, but do you see all these red curves right here? You want to take all of those red curves and turn them into a contour diagram where this is z and this is y. What would you see? How many curves would you see? 3 curves. You would see one of them like this. You would see another one like this, and then you would see another one like this. That goes up and then down. You would see those 3 curves. This is the diagram that I would expect you to draw right here. That's the diagram I would expect you to draw. The clean version of this, you can see it in the answer key, everybody. The clean version of this, I don't have the answer key up here, sorry. Let me get to it. Single, it's right, sorry. Algebra 1, they want to graph things too accurately. This is important. I'm looking for the general structure and the general shape, not something that's hyper accurate. So what matters on a contour diagram? How close the contours are together? And is it the right shape? What shape is this? You need to know what shape this is.
That's an ellipse.
It's an ellipse. What's the best way to graph an ellipse? Anybody know? Plot intersection. Oh, thank you. Plot intercepts, right. Plot intercepts. Oh, thanks, everybody. So when x is 0, what's y? On this one, when x is 0, what happens? What's y equal to? Or. So on this one, it's 1 or negative 1, right? I'll just put that in there, 1 or negative 1. What happens when y is equal to 0? Plus or minus root 2. All you need to know is root 2 bigger or less than 1? Bigger. So what we're going to do here is this will be a little bit further out. So what shape is this? Is this an ellipse? Yes. And what's the output for this one? What's the output? 2. That's the output. It's an ellipse like that. What should I choose next? 4. So if I choose 4, 4 is equal to x squared plus 2y squared. If y is 0, what's x? Plus or minus 2. So this was 1. The next one's going to be 2. And what shape are you going to get? Oh, x is... when y is... Thank you. When x... So it's... This was root 2 right here. So then it's 2 right here. So when x is 0, what's y? When x is 0, what's y? This is not a trick question, everybody. When x is 0, what's y? We're just going to be silent. Plus or minus root 2. So it's 2, and then this one is root 2. So it's not. That's a little too close, isn't it? So where should it be? It should be like right, oh, too far away. There. So this is root 2. So what shape do you get? Another ellipse. It looks like this. But what value? What's the output value for this one? What's the output value for this one? 4. So when you're doing the contour diagram for this, what am I going to grade it on? Are the z values equally spaced? So what are the z values? 0, then what? 2, and then 4. And then the general shape of the contours. What are the general shape here? It's a point, and then it's a ellipse, and then it's a ellipse. It's just going to be concentric ellipses. That's it. You would get full credit for this. Right there. Is this thing going up or is it going down? They're getting bigger, so it's going what? Up. It's going up. That's it. Don't get hung up on making it perfect. Perfect is absolutely the enemy of good, especially here. Kind of maybe sort of makes sense? Okay. Let's pick a different one here. There we go. Okay. It says, draw 2 different cross-sections along north-south and 2 different cross-sections on east-west for the population densities. So what that means is you make a cut. This is a 3-dimensional surface. The higher it is, the more dense the foxes are. There's more foxes where the number's higher. Do you understand what you're looking at? Do you understand what you're looking at here? Yay? So the cuts I would make, you can choose where to make them, but you're just literally going to graph what you do when you cut across. So east-west is side to side. So let's do an east-west cut right here. East-west cut right there. So what happens, basically, it's asking what happens as you walk. If you were to walk on that line, what would happen? What's the population right, I think they label it, what's it right here at this point? What's the density of the population at that black line? 0. And then it crosses here, and it's what? 0.5, and then it's here, it's 1, and then what is it? 1.5, and then it's 2, 2, 1.5, 1.5, 2, 2, 1.5, and then it goes down again, right? All you're doing there is you're making a 2-dimensional graph of this cross-section. Imagine you had this. Take this right here and turn it into a 3-dimensional map in front of you, like it's bubbling, and then you cut it and look at it from the side. What would you see? What would you see? You would see something that looks like this. This would be the kilometers east, and then this would be the population. Does everybody see what I mean there? What is the density from 0 to here? What's the density from 0 to there? It's 0, right? There are no foxes. So what's going on? From 0 all the way to about, what's this value right here? If that's 60, I don't know, maybe that's, 40. So from like 0 to 40, what is it? It's 0, right? And then what happens all the way to about, let's say 70. What happens from 0 to 70? Is it increasing or decreasing along the blue right here? Is it increasing or decreasing from here to here? It looks like it's increasing pretty steadily too, right? Pretty constantly. it goes from 0 to what? 0.5 to 1 to 1.5. Are you with me? Freaking teacher technology Olympics here. Maybe we could get a leaf blower going. Was it this class that had a leaf blower going earlier this year? I had a class earlier this year where 2 different leaf blowers were going outside. Yeah. That was super helpful. Okay, so what does it do? It then goes up or down, the density. If this is 70, what does it do? It goes all the way up to what? 1.5, right? It looks like it goes up pretty steadily, right?
Why don't you write with like vertical lines if it changes from like infinitely small distance to another? If you cross a line, it's not going up.
Well, this is only the slice representation. It's a continuous function, right? So this honestly, it should be smoother than this. Most likely, it looks like this. Honestly, it's more like probably a smooth curve like that. So then at 70, what does it do? Like from here to here, what does it do? Does it rise on the purple or decrease on the purple? From here to here, it goes from 1.5 to what? 2. But it's wider, right? So is it going to be steeper or shallower? Shallower, like this. And then it stays the same, and then what does it do? It goes, what happens on this next blue? It goes down, evens out. Do you see how I'm building this, everybody? Just build it little piece by little piece. So what's it going to do? It's going to level off, and then it's going to go, what's it going to down, right? Goes down a little bit, and then it's flat at 1.5 for a second, and then there's a little peak here, because it goes back up to 2, right? Do you see how it goes back up to 2 for a split second? So it's going to go back up to 2, and then it's going to go down. Do you see how you can do this piece by piece? This is the key thing I need you to walk away with on this. This is what you would get if you looked at it from the side. If I had a 3-dimensional topographic map right here, and I sliced it, and then I looked at it from the side, this is what I would see. Does that kind of make sense? I really wish I had I wish I had some sort of like 3-dimensional thing I could stretch things around and manipulate here, but that's what this looks like if you did a vertical slice. That's what it's asking you right there. Okay.